Hi. Okay. Real quick, let's go over how we're going to answer the questions about like density layering. Things that are less dense are going to float. And then as density will start to increase, those heavier or more dense things will be towards the bottom. But this is how we're going to answer it for your exam questions. Okay. So density layering in the ocean. And the things we know that affect density are salinity, and pressure and temperature. And temperature is the most dominant factor. It's the biggest thing that will affect density, which is why no matter what at the surface, we're going to have water that's really warm. And then the other thing in this little Google Slides is the varying amount of oxygen in the ocean, which is this second question down here. So why there's differences. Additionally, if you want to kind of hear more about a thermocline, this video that I put on this front page is from the Scripps Oceanographic Institute. It's a pretty relatively short, things like 11 minutes, and it's a pretty good another just explanation of your thermocline, the halocline, and the pycnocline. I don't know if you can hear Olive. Hold on. Sorry. No. Sorry. Okay. So again, I wouldn't even try to even answer one of these questions without drawing it out first. So this is one we did yesterday. Describe how salinity, which is salt in water, it's the total measure of dissolved solids in the ocean in parts per thousand. So it's how salinity can produce different layers, right? And those layers are all based on density. Your least dense at the top, moderate density, highest density at the bottom. And then how mixing can occur. And I kept saying this, like, it doesn't matter if it's mixing, like if they're talking about temperature or if they're talking about density, if they're talking about salinity, it doesn't matter. Mixing is still going to be done the same way. So again, I sketched it out and you can see it off onto the right side there. So there's only 3 like parts in the water column, no matter what. You're going to have the surface layer. So what is the sun doing to that? Does it have an effect? Or is there an atmospheric effect? Like, so for the oxygen or even salinity, like if we're going to have some precipitation. Olive singing, I'm going to shut my door. Okay, so for salinity, this doesn't say why, it doesn't say explain why. So we're just going to, it says describe. So describe command word means just what do you see? If it was explained, that would be the why. So at the top, the surface, salinity is typically low. And if you change salinity, that can affect density. Now that first mark, changing salinity can affect density, it does not have to be the very first thing you say. But it is a part of the mark scheme. It doesn't have to be the first thing, though. As long as it's mentioned, you can get a mark for that. So at the top, you could say that reverse argument, sorry. You could say that if salinity is low, the density will be low. That will cause it to float. Or you could say if salinity is high, density will be high, and those things will sink. It kind of made sense to say that the lower salinity will float right there because you're talking about the surface. So kind of like the salinity is low at the surface, and then like, okay, why why is it at the surface then? But that's because it's less dense, and in less dense things will float. The reverse argument of that we wrote is that salinity is high, density will be high. So obviously the inverse, if salinity is low, density will be low. So salinity is typically low at the surface. If the question said and explain, you would put there could be in like influence of freshwater runoff or precipitation or melting of sea ice, and that will dilute the water. But it didn't say explain, it's just describe. So below that, below the surface layer, you're going to have like your mixed layer. It's where the halocline is. So you have a layer of water that has the greatest change in salinity with depth. And then at the bottom, you already said high salinity will have really high density. So at the bottom, as your depth is starting to increase, like you're getting deeper, salinity increases. And why is it really salty towards the bottom? And that's all because of gravity. Gravity is going to be pulling things with mass down towards it, and that always happens. All right. And then at the bottom, how can mixing happen? So winds can produce turbulence, and that could result in mixing. If you have seasonal changes, so it's going to like turn winter, the surface water won't be heated as much. Ultimately, it's going to start to lose temperature, but not really fast because water has really high heat capacity, so it can hold its temperature well. It does also take a while to heat up as well. But changing the temperature, mainly like decreasing the temperature, that could increase the density of the water, and that will cause that surface water to sink. The next one, temperature variations. So this is the thermocline. And whenever I do this too, I've taught this multiple ways, always sketching out the thermocline and then saying, okay, why is it doing this at the top? Why is it doing this in the middle? And then why is it doing this at the bottom? So again, I also coordinated it with these 1, 2, 3, like the 3 different sections within the water column, and then its explanation off to the side. So describe, again, just see, talk out what you see. Describe how temperature gradients, when you read gradients, just think differences, right? If you guys have differences in your academics, it's graded. Like that is a gradient. We grade it. So gradients, how they form in the water, and ultimately it's going to produce layers. And that's, again, those density layers. And then how they can mix. So this one's only 5 marks, but surface water is warmed by the sun. Warm water is less dense than cold water. So warm water will sink. Or you could say, high temperature has, I said sink, I didn't mean to say that. You could also say, it doesn't say warm water is less dense. You could say high temperature causes a lower density. Warm water will float. Yeah, I didn't mean to say sink just a second ago. Warm water will float. And you know that heat rises. And if I said, okay, why? You would tell me, oh, because it's less dense. And that's all because they're kinetic energy. Kinetic energy of the particles are going much faster, and that decreases density. For the second part, so this is where your thermocline is. So now you've like backed off from the sun, you've backed off from that heat source. The temperature is going to fall really fast. If any of you guys are ever like in the north while it's snowing, and you have the heat on in the car, as soon as you turn the car off, it starts to get really cold really fast. The opposite happens here whenever we turn the air conditioner off. The car gets really hot really fast. And that's really because there's a huge temperature difference or a really big temperature gradient. So below that, you have an area where the temperature changes the most with depth. And then at the bottom, temperature goes down as depth increases. So as the water gets deeper, the temperature will continue to decrease. And it's not the reverse of that. It's not, if things get, it's not that, sorry, temperature is controlling depth. It's depth is controlling temperature. And then how does it mix? So it can get mixed by wind turbulence, lowering the temperature at the surface, which will increase the density of your surface water because it's colder, and that will allow it to mix. And then there's another term here from this mark scheme, and it's convection. You already know convection. Convection is like what happens in an oven. Ovens heat from the bottom, so it's convection oven. If you guys are pretty good at like earth and space science, convection happens in the mantle of the earth with magma. Magma gets heated at the core, and so it rises, and then it starts to cool down, and it'll sink again, and that causes those convection currents, which ultimately moves our plates, the lithospheric plates. Lava lamp. It gets hot at the heat source, and then it starts to move up, moves away from the heat source, cools down, and sinks. That is a convection current. Heat rises and cool things sink. Last one. Okay, so how oxygen is different in the water. So again, describe the reasons, or discuss the reasons why. Like there's differences and there's that variability. Something's varying, or if there's a gradient, it's different. Why there's differences in the amount of oxygen in the water. Again, I wouldn't want to do this just off the top of my head. I would definitely want to draw it out. So that's why I really encouraged you guys to do all these short graphs in your notes, and definitely have them on your vocab. So at the surface, you have really high sun penetration, and that will allow for photosynthesis. So that first mark is actually those first two lines. So there's photosynthesis going on at the surface, and that's because you have high sun penetration. Photosynthesis produces oxygen. You get another mark for saying that, so letting the grader know that you know photosynthesis produces oxygen. Turbulence or wave action is really high. This will help oxygen dissolve into the ocean. Turbulence has nothing to do with salinity. Although, yes, it can help with mixing, but it's not like your waves are eating salt in the air or even fresh water. Turbulence is good for mixing, but it's not going to, cause anything different with salinity. I'm only saying that because I know some of you guys in class were saying there's turbulence at the surface. I'm like, there is, but that doesn't cause salinity to be high or low. So turbulence is good to mention for mixing, and then of course it is a main factor in the oxygen. Below the surface, so once we're kind of out of that first 50 meters or so, below the surface, the oxygen concentration decreases a lot. And it's not because there is no more photosynthesis or photosynthesis is decreasing. That is happening, but that is not the reason why oxygen is going down. Again, it's like I said with a job, if you made $400, you have $400. Now, even if they start to cut your working hours down, you still have $400. Where did that go? You spent it. So even though photosynthesis can't be happening that much, we're not adding oxygen in. Don't care. Where did it go, though? The stuff that you did have, where did it go? And it's below the surface. So oxygen concentration is low, and that's because you have a lot of organisms there doing cellular respiration. And we're not adding extra oxygen in. Instead, it's now being used up. Where at the surface, it's being added in and being used up and added in and being used up. And then, so the things with temperature and depth, you could in the beginning say at the surface, temperature is high temperature has low gas solubility. You could say that. And you guys have a little foldable for that. This one. So temperature, you know that low temperature holds gases really well. And that's how I would say, how do we have our carbonated drinks? But you could also say it at the bottom. So it doesn't matter. As long as it's mentioned once and you can have the reverse argument, that's fine. The other reason is depth or pressure. So because those go hand in hand. As the ocean gets deeper, or as you go deeper into the ocean, the pressure definitely increases, the water pressure. So if depth or pressure have an effect on gas solubility, and then more specifically, high depth or high water pressure has really high gas solubility. You could also say the reverse argument. You could have said it maybe towards the surface. You could say the depth is really low and the water pressure is low, and this does not hold in gas as well. As long as you said it at least once, mentioning the depth factor and the temperature, then you're good. There you go. That's all.